In this video, we'll have a look at setting up the input channels into the inertia-free software and hardware system. We have 5 available input channels and 2 math channels, which we'll deal with later on. For the moment, let's look at the hardware channels. You can see them displayed here, down on the bottom of the Dyno screen while we're testing. They have alarm limits applied to the channels as well, which we'll also look at. So they are set up from within the setup sensor configuration screen. Here are our 5 input channels. We can freely name them. We can select the sensor connected from a drop down. Normally they are set onto 0 to 15 volts just as a default display. On the inertia-free hardware, there's a switch on the side which allows us to select 0 to 15 volt range or 0 to 5. By default, they're set on 0 to 5 because they are in fact 0 to 5 volts is the range of the internal hardware. Putting it to 15 volts divides the voltage down so that we can still read it on a 0 to 5 volt scale. So if I want to measure battery voltage, then I would flip the switch up to select that range. So we have a huge amount of pre-calibrated sensors that you can see here with many air-fuel ratio meters and calibrations already done. So often it's very easy to set the channels up without even any thought at all. So if we look here, let's set channel 1 up, and let's say we've got an air-fuel ratio meter, and let's say we've got one of our fantastic WB2 DTec meters. We can set it on lambda or air-fuel ratio, so whichever you'd like to display. Let's say lambda, my preference, and we'll call that lambda. Channel 2, let's say exhaust temperature. So maybe we've got a DTec exhaust temperature here, and we've selected this one. So we'll call it BGT. This one here, we might leave on voltage. So I'm using 0 to 15 volt range, so I would need to go and switch channel 3 switch to the upright position on my hardware. Anytime I wish to see the calibration for these channels, so anytime I wish to actually see it, I can click on the graph symbol next to it and it will show the calibration down the bottom. So there's the calibration for the air-fuel ratio meter. So it shows voltage along the bottom, millivolts, so 0 to 5 volts, and the lambda scale down the side. And I can always check it. So I can see at 2.5 volts what I have coming out. So that's pretty straightforward. But let's do a custom sensor, one that we don't have in our list here. So we'll make our own. Let's say that we have a pressure sensor. So let us come over here and we'll go add a new sensor. Now that new sensor we'll call my pressure. Whoops. My pressure. So what we have here is the actual data for that sensor. So 0 millivolts, so with no voltage coming out of the sensor. Let's say that this sensor has 100 kPa. At 5,000 millivolts, so 5 volts, this sensor has 400 kPa. Done. So what I've done is create a sensor called my pressure with that calibration data. And here it is on the list. So I can edit any of these, by the way, if I've already created them myself. So this my pressure with my new sensor. So on channel 4, I can call it whatever I would choose. I'll select its calibration. My pressure was the one I made. There's its calibration graph, so I can check that it behaves as I wish. So 0 volts was 100 kPa. At the top there, near 5 volts. So that matches. Perfect. Job done. So we're going to close that screen down. We can also, by the way, save those calibrations to a file. So it's telling me I might need to check my alarm settings. So there we go. Now when we view data, lambda, exhaust gas, voltage, kPa, my custom channel. We can also do our own non-linear calibrations as well, which I'll show you in a minute. But before that, I might just show you a handy little screen that I like to use. Utilities, data diagnostics. This is great for troubleshooting sensors and checking the inputs. What we have here is, you can see it's currently displaying them, and we can actually read live whatever values, I'm using a little simulator here, whatever values are coming into the system. I can plot them out as well, so choose a channel to plot, maybe channel 2, exhaust temperature, so I can monitor it while the sensor's reading on the vehicle. I can also log it from within here as well, so I can save it to a file, and I can also display in millivolts. So this is the actual voltage coming into the hardware. Very handy for troubleshooting. If a reading doesn't make sense, you come and you check that you actually have a sensible voltage coming into the system. When I go back to units, I get my converted and scaled system. I can also actually, if I have my hardware tacho fitted, my RPM adapter, I can also display it here as well to check that that input is working. So this screen is designed for checking all your input channels into Dyno. There's alarm settings and everything as well, but we won't go into those. So that's a really handy screen. As I said, there is alarms, so there is a screen to set alarms, upper and lower or out of range scales onto all of the gauges as well, and to save those. So that's basically it. There is a little bit more advanced setup that we can actually do. If we had a non-linear sensor, so let's say channel 5 here, non-linear being something like a coolant temperature sensor, which is a variable resistance. Here's a common Bosch one. I'll choose a degree C calibration. So you can see it has a curve applied to it. The calibrations that you were entering here were just straightforward 2-point calibrations, which is normally all that's required. But you can generate your own complex non-linear curves as well. To do that, we use this function here. Within this screen, we can effectively enter the millivolts in versus some output units. So if I have at 0 millivolts input, my output might be minus 40. It's a table, so I'll only enter a couple of points and it will interpolate the data. At say 2.5, come down a little bit. So 2.5. Let's make it say room. Let's say it was a temperature sensor. So at room temperature, So 25. So it's starting to fill in the table on this side. So it's interpolating the data between those points. And if we pick another point of interest, say higher up the scale, and we tell it here it's 300, it's now graphing that between those data points, and it has filled in a table over here of all the data, including interpolating it all the way up to 5 volts, even though my last data point was only 4.5 volts, 4,500 millivolts. It's interpolated the table. Now that's not a very nice looking piece of data there. So what we can also do is here, we can tell it to curve fit. So it will curve fit the data. I haven't got very good points there, so it's a little bit funny curve with it kicking up at the end. And it will interpolate and fill out the table for me. So I can save that table, save this table as a sensor name, and then it would appear in my drop-down list, just like any of these other sensors are. So you notice these were pre-calibrated non-linear sensors, and they don't have the usual voltage 1, voltage 2, value 1, value 2. But that's it. So that, you might call that engine coolant temperature. If we were using a sensor like that, a resistive sensor, you'll notice it has a note here, 1K pull up to 5 volts. If we flick the little switch, it's already built into Dyno. If we wired it up to channel 5 in this case, and we flick this little switch here, channel 5 up, that would internally add what we call a pull-up resistor, and we'd be off and running. So it's quite simple. We also have filtering here, so we can smooth the sensor inputs out if they were erratic, which we can sometimes get with mild interference. We also have a calculator here. We also have a more advanced calculator for those playing with voltage dividers, so taking a larger voltage and stepping it down within the 0 to 5 volt range of the system. So quite a sophisticated little design tool here. But generally, most users, you'll be going in, naming your channel, picking a sensor, or doing a simple calibration as we did, and that's it. And that will calibrate and scale my gauges. So thank you very much. I hope you join me for our next little information video. Thank you. Bye.